All right, welcome to the video of discussing how to prove on a coordinate grid if we have a parallelogram, rectangle, rhombus, or a square. When they're asking about all of these, it is very, very important that we test for parallelogram, rectangle, and the rhombus. We'll discuss what happens, why we don't have to test for square in just a minute. Your parallelogram and your rectangle could be tested at the exact same time. I will give you a heads up. Please be prepared to pause to write some comments down that I have on this video. To test for your parallelogram and rectangle, we'll put parallelogram and rectangle test. We'll go ahead and use the slope. And with this, in my previous videos, we used the slope formula. Guys, it's on the graph. Just do your rise over your run. Make this nice, quick, simple, and sweet. So the parallelogram and rectangle test using the slope, we are looking at parallelogram. Are opposite sides parallel? So let's take a look. Let's look at KL right here. We use our rise over our run. We're going to find out that we're going to go down 2, and then we're going to run 9. So we have a negative 2 over 9. The opposite side, JM, we do our rise over our run from J to M. We're going to go down 2, make it a negative 2 over, and we're going to find ourselves running 9. So these are parallel. You have to check both pairs, okay, both of them. So then let's look at the other sides over here, JK. Make sure these are parallel as well. With JK, we're going to find ourselves rising up 6 and then running 7. It is a positive 6 over 7. Then with opposite side over here, LM, from L to M, we're going to find ourselves rising 6 and running 7 as well. So these are going to be parallel as well. So with this being said, we can now conclude that we do have a parallelogram. Okay, we have opposite sides are parallel, telling us, yes, we have parallelogram. Now, when we look at how to test for the rectangle, we need to look at, are the consecutive one after another, are they perpendicular, giving us the 90-degree angle? So we need to look at these two slopes and say, do we have opposite reciprocal? There's nothing in common with these two slopes. So we do not have perpendicular sides. We do not have a 90-degree angle. So here we can write in consecutive sides not perpendicular. Therefore, it is not a rectangle. But now we need to test for the rhombus, okay? Because it is not a rectangle, it cannot be a square, okay? Because again, with this flow chart, in order to be a square, it has to have these properties. Since it's not the rectangle, it cannot be a square. But we need to test to see, is it a rhombus? Doing this, you can use distance formula for all 4 sides and figure out if they are all congruent, but there's a much shorter way to test for the rhombus. If we take a look at the diagonals, we remember one of the rhombus properties is that the diagonals are perpendicular. So we're going to need opposite reciprocal slopes. So if we take first, let's go ahead and draw in diagonal KM so we could find the slope of it. We'll do our rise over our run. Here, segment KM. We're going to find ourselves falling 8, giving us negative 8 over, and we're going to run 2. This simplified will be a negative 4. If we draw in and find the slope of segment JL, this diagonal right here, JL, we're going to find ourselves rising 4. It is a long run, but I'll go ahead and let you know if you count that over, you're going to have 16. So this will be 4 over 16, simplifying it to 1/4. The reason we need to have our fractions simplified. What we are going to notice is that we have opposite signs, and that that -4 changed to a positive, and that we flip the fraction because it's 4/1, we flip it to 1/4. So here we can say diagonals are perpendicular. So we do have a rhombus. Now, for a square, again, because it is not a rectangle, it is not a square. So we'll write that in. Actually, I know you guys are probably writing it right. I'm gonna write that kind of over here. This is gonna be a rhombus. And then note that not a square because it's not a rectangle. Okay, go ahead and pause and get that written down. On B, go ahead and plot the points and label them and connect them, please, so that we can find slopes. I've already done that here, as you can tell. Draw a line. Another pen about to run out. So we'll go ahead and start off with, like we did on 1A, we're going to go ahead and do the parallelogram and rectangle test using the slopes of the sides. And we'll go ahead and start here with AD, segment AD. Our rise is going to be 3, and our long run, is going to end up being 9, simplifying to 1/3. The opposite side, BC, we're going to find ourselves rising 3 and running 9 again, simplifying to 1/3. So here we have one pair of opposite sides parallel, always check the other pair. So over here we have segment CD. We're going to find ourselves falling 9, so that's a -9, and then running 3, -9/3. Opposite side over here, segment AB. We're going to find ourselves -9/3. And I did exactly what I told you not to forget to do. I forgot to simplify it. -3. So both pairs of opposite sides are going to be parallel. So here, go ahead and write that in, what we did earlier. And what we're noticing now, if you look at consecutive sides, AD and CD right here, they are going to be perpendicular because we have opposite reciprocals. These slopes are opposite reciprocal, therefore they are perpendicular. And this is going to be a rectangle property for right angles. Consecutive sides are perpendicular, so this time we do have a rectangle. So we need to now test it for the rhombus. We use the diagonals being perpendicular, like we did on the previous problem. And if it is a rhombus, then we'll talk about what happens then. So let's go ahead and draw in our diagonals. Here is segment DB. Go ahead and for our rhombus test, go ahead and take segment BD. We're going to find out we're going to be going down, so this will be a negative slope, and we're going to end up going down 6, and then we're going to run 12. So we have -6/12. This will simplify to -1/2. We draw in our other diagonal, segment AC, right here. We'll find ourselves this is a positive slope, and we're going to rise a total of 12, and we're going to run 6. So we have 12/6, which then will simplify to a +2. So we look at -1/2 and +2. These are opposite reciprocals. Therefore, these diagonals are perpendicular. So we can conclude that, yes, this is a rhombus as well. All right, writing that down. Important that we're always writing down these properties we're using. Now, because we can now classify this as a parallelogram, a rectangle, and a rhombus, they have all of these properties on this flow chart, it is a square, okay? But in order for it to be a square, it has to first have properties of a rectangle, then it has to have properties of, parallelogram, then it has to have properties of a rectangle and rhombus to come back together. Like up here, we did not have a rectangle, so it's not a square, it's just a rhombus. Now, that can sound a little bit confusing. But here, we'll go ahead and note down here, the property here, we have both a rhombus, I'm going to put that in letters because I'm going to capitalize it, and a rectangle. So we can conclude in the end, this is a square because we were able to prove it's all of them. Hopefully that makes sense. Go ahead and ask your teacher if you have any further questions.